For the vector function r of t equals e to the ti plus 2tj, we're going to sketch the curve given by r of t, find r prime of t in terms of t, and then sketch r of t and r prime of t for a particular value of t, that value being t equals 0. First, let's sketch the curve. Rather than plotting a bunch of points, what I'm going to do is express this parametrically. So x is equal to e to the t, y is equal to 2t. And if I can solve for t in terms of x, then I can substitute for t and I'll have y in terms of x and I'll know what to graph. Since x is equal to e to the t, the natural log of x is equal to t. That means that y is equal to 2 times the natural log of x. Let's graph this on a grid here. Give myself a y-axis and an x-axis. Our graph goes through the point 0, 1, or our curve, I should say, and it's got the shape of a logarithm and it's scaled up by a factor of 2. And that's roughly our curve. You know what, I did something that I do out of habit. I put an arrow on both ends of this curve, and I shouldn't have. This curve has a direction as t increases, but we can see that as t increases, both x and y increase, and so this grows in the direction in which I drew it. Now for part B, we're going to find r prime of t, which is going to be a fairly straightforward endeavor here. The derivative of e to the t is e to the t. I'm going to use angle bracket notation here. And the derivative of 2t is 2. And so there's our r prime of t. For part C, we're asked for both r of 0 and r prime of 0. Let's just double check all that. Yep, r of t and r prime of t for t equals 0. For r of 0, we've got e to the 0 and then 2 times 0. So this is going to be the vector 1, 0. For r prime of 0, we've got e to the 0 and then 2. So r prime of 0 is equal to 1, 2. Now I need to make an important distinction between these two vectors r of 0 and r prime of 0. R of 0 is a vector in standard position, the head of which is a point on the curve. And using some color coding here, I'm going to draw that vector. And it's got its tail at the origin, and its head is a point on the curve there. So that purple vector there is r of 0. I don't like where I put that, so I moved the r of 0 there. The important distinction is that r prime of 0 is a tangent vector, the tail of which is at the point of tangency. It is not in standard position. Its tail is on the curve. So on the curve here, I'm going to draw the vector 1, 2. So 1 unit in the x direction, 2 units in the y direction, and I end up with this vector here. That's the vector r prime of 0. So remember, as I said before, the tangent vector is, the way I think of it, the direction that a particle would move if no force were acting on it, right? If it were able to break away from the curve at a particular point, it's the direction in which the thing would fly. Or given the analogy I used before, it's where the roller coaster would go if the track broke at that point. So the tail of the unit, or the tail of the tangent vector, is on the curve. The tail of the position vector, though, is its standard position, so its tail is at the origin. Well, since we were asked to find these two, I'm going to put them in a box, and then they are also in the picture and labeled. Folks, I am demonstrating proper technique for you. Next up, find the derivative of the vector function r of t is equal to the sine squared of ati plus te to the btj plus the cosine squared of ctk. Now we're going to take the derivatives of each component, right? We're going to go component by component, but I want to keep this in the structure of a vector. So I'll just write it as r prime of t is equal to, and for the sine squared of at, we're going to use the power rule and also the chain rule a couple of times. We get 2a sine of at cosine of ati. And this is all coming from, the 2 comes from the power rule, sine squared, right? And then we drop the power by 1. The derivative of the sine function is the cosine function, so that's where cosine is coming from, of at. And then the derivative of at is going to be a. So that's where the 2a and everything else is coming from. Plus, for the j component, we're going to use the product rule. Now for the product rule, we're going to do u prime v plus uv prime. And for both of those, we're going to end up with an e to the bt. So I'm going to go ahead and factor out e to the bt ahead of time. And then thinking about the product rule, u prime is going to give me a 1 in place of t here. And then plus uv prime, we're going to pick up a t times b. If that went a little quick, then go ahead and pause it and double check the work there. For the k component, we're again going to be using the power rule and the chain rule. The derivative of the cosine is going to be negative sine when that pops up. So negative 2c times the cosine of ct sine of ct k. And we were just asked to find the derivative, so that's it.